So I'll go ahead and start. I was going over my, I believe I talked last time about how I like games. And so later today we will be playing, some of us will be playing a game. It's completely voluntary. You don't get any extra credit for being a volunteer / victim. You just might have some fun. So we'll keep that for later. But again, I do think games are a great way to learn. And as it turns out, this lecture, I was reviewing the past couple years for this lecture, and we typically have, let's see, the projector is muted. We typically have like 20 or so minutes left in this lecture, so I do want to make sure that that is filled. So there's plenty of time. Now, if you haven't read or watched the videos for Module 2, let me just go over that. You should do so as soon as possible. Right, so every week, before the week, ideally you want to watch / read as many of these videos as you can. Now this stuff is a bit of vocabulary plus math that you already know with some slight additions. Right, what do I mean by that? Today, because I'm going to be reviewing what you should have gone over anyway, because I believe in basically presenting things multiple times to students. Especially at this early level. So the things that you should already know, PEMDAS, right? Parentheses, exponentiation, multiplication, division, addition, subtraction. Basically, your order of operations, right? It's going to work pretty much the same way in here as it does in your math class. We just happen to have a few extra operations that make logical sense, and we slowly expand on that. Now, that being said, except for like the modular operation, which is the one the new one you're going to be learning today, things like the order of operations for and or, and other things we'll be learning later in the class, nobody really keeps that memorized. What do we have memorized? What we learned in algebra, which is, please excuse my dear Aunt Sally. Or if you're from a Commonwealth nation or one that learned from the Commonwealth system, BEMDAS, brackets, right? Brackets instead of parentheses. So this week is all about kind of using your Python programming as a really powerful calculator. That's really what we're doing this week. We're less writing extremely powerful programs and just kind of just taking advantage of a calculator here, which is very nice. So again, what we're going to do over here today, like I said, Q&A review session, short exercise. So this should be stuff that you hopefully would do, but every week you kind of want to go through these and either watch these videos that I have here, which go over section by section of the chapter, right? So every section I have a video, and they are not that long, right? Over here, if we skip to data types,
so we've
I think
that
is me going over the data types. This is 5 minutes long, right? This one over here is reassignment.
Welcome to the first stumbling
That's 5 minutes long. These aren't particularly short. When I talk, my aim and objective is that you're always going to be, especially for like flip style lectures, which is, I would say is half flipped because I work out the assumption that you would be watching this but may have missed some. I never make these more than 2 hours long in total length. This is the rule I took from the first class I flipped and for this one. So ideally, again, you want to watch these / read the textbooks. They cover the same material. It's just that I know that for some of you, working at your own pace versus watching a video might be more advantageous. All right. So let's talk about our programming stuff. So first off, what you'll want to do is, what I'll be doing, and you can follow along too, is I'm going to be opening up idle to do this, right? Which is just simply running idle. And when you open idle, you get this screen. Now idle is our shell. It is our way of it is our editor and our basic way of interacting with Python. There's a lot of different tools out there for working with Python, right? We have the Python interpreter installed on our computers now. This is the program that basically says, given Python commands, I will turn them into instructions that your machine will understand. And so there's ways to interact with this machine. One of these is idle, but there's also VS Code, there's PyCharm, there's Spider, there's all sorts of different tools. I like idle right now because it's minimalistic and you didn't have to install anything else. It comes pre-installed when you install Python, right? So this is fine, and it opens up like this. It opens up in what we call a REPL, read, evaluate, print loop, and you can identify it by this series of greater than signs. And basically, this is kind of a question-answer format for the program. So you can ask it various things, or rather, you can ask it to evaluate different expressions, right? An expression, right, is something like this, 2 plus 2. Now, the math here isn't going to be hard in this class. I never try to make it hard because the assumption is you've already learned how to do math, and that's your math professor's job to make your life hard with math. Here, I'm just using math because we got to use it. It's a tool, right? So 2 plus 2 is equal to 4, right? We can do kind of different expressions with this type. The question is, what are we doing and what can we do stuff with, right? So when we work with numbers, what do we really mean by this? Numbers, we deal with two types of numbers in Python. And programming languages in general treat these two types of numbers extremely differently. Okay, the first type of numbers is what we call integers, and they're exactly the same as integers in mathematics. What are integers? Those are the nice, friendly numbers that we all like. 1, 2, 7, 12, but also include things like 0 and -5, right? They're your positive and negative whole numbers, right? 6, 15, these are integers, right? Integers aren't scary at all. We've been using them since forever, right? They're all your whole numbers. Okay, and there's no trick questions about whether 0 or not is an integer. If it's a whole number, it's an integer, right? And you can do all the things you would expect you can do with these integers, right? You can add them, 5 plus 4. You can subtract them, 5 minus 4. You can multiply them, 5 times 4. You can multiply them a whole lot. And Python doesn't care. Other programming languages care, right? There's a certain actually size limit to certain numbers in other programming languages that you would have to memorize, around 2 billion and -2 billion, right? And there's actually different sizes, other types of there's other different sizes of numbers in case you need bigger numbers that you would need in other programming languages. Python's like, why would I care? We should simply adjust that based off your need, and so we're just going to make the numbers as big as we need. So Python is really good at just dealing with arbitrarily big numbers. Now that being said, right, at some point, if you make your numbers too big, your computer might have some trouble with it, but it requires getting to really big numbers at that point, right? Now, the other thing is that, is division, right? That's our other operation. Addition, subtraction, multiplication, division, right? We can do that, so we can do something like 10 divided by 2. Like I said, math is going to be easy here. And this one is going to throw us for a bit of a loop for a second, because it introduces us to our other data type. Rather than returning 5, it gives us 5.0, our floating point number. This is the other type of number that we deal with, floating point numbers, called so because they have a floating point, or what we often call a decimal in it. This is not a particularly scary thing, right? The math is still there, 5.0. And this is just simply an interesting quirk of the Python programming language to kind of help with the unexpected behaviors in other programming languages. Let me explain for a second, right? If I were to do 3, let's go ahead and do another easy division. 3 divided by 2, right? Again, easy division, 1.5, right? 1.5, right? However, in other programming languages, you would get the answer 1, which is very confusing. Now, why is this? Because in other programming languages, if you take an integer, divide it by an integer, you get an integer. And integers don't have floating points, so they just throw away the point and everything that follows it, so hence 1. We can actually see this behavior in Python if we want it. If we want it. It assumes that anybody starting out in Python doesn't want to throw any information away, right? If you do 3 divided by 2, it expects that the user probably wants to see 1.5 and not 1, right? But because it's useful, we have a second operation for division, divide, 2 divides. And that gives you given an integer, divide by an integer, you get an integer, right? Basically, see how we just simply toss this integer out. Let's go ahead and do 11 divided by 2, right? That should be 5.5, right? 11 divided by 2, we throw out the other bit, right? 10 and a half, right? Because we couldn't fully divide this one. There's going to be a lot of 4th grade arithmetic here, okay? A lot of 4th grade arithmetic today. Stuff that we haven't had to deal with in a while, and that's okay. Okay? So, now, but for the most part, this shouldn't be too scary, but you'll just keep in your mind right now, there's 2 division operations. One where it's the kind of division operation you'd want to do on a calculator, which gives you a floating point number, and a division operation that will give you an integer. How important is knowing that this will give you 5.5 or doing this will give you 5.0? I'll tell you how important it is. It's 2 points on exam 1 important. There you go. Okay? So, beyond that, it's not that important. It's one of those things that's fairly straightforward to solve, right? You understand the difference between divide and divide. And in case you forget that it's important to know for the exam, don't worry, the practice exam will get you covered for there. For all exams, I do try to provide a practice exam. And the way those practice exams work is that when I was initially writing my first exam, I made twice as many questions as I needed and tossed half of them into the practice exam. That makes it a very accurate representation of what your exam will be like because it's from I just simply generated a pool of questions and just arbitrarily chose half to go into the practice exam. And I typically chose the harder half to go into the practice exam because, if you try something harder and then you get to the exam and it's easier, it feels really good, right? So, now let's talk more about those floating point numbers, shall we? Floating point numbers do the exact same operations, 5.5 plus 0.5, right? Again, we're not trying to do any trick questions with the math over here yet. 6.0, right? Completely expected operation over there, right? 5.5 minus 0.5, 5.0, right? 5.5, well, let's keep it easier so you can do it in your head. 4.0, okay, times 2.5. Let's not do 2.5. Yeah, why not 2.5? Times 2.5, right? That should be 10. 10.0 in this case, right? And let's do 4.0 divided by 1.5, which gives us an interesting rounding number. And you'd expect this to be 2.66. We see a bunch of repeating sixes because in decimal, we have an issue with representing 2/3 as a decimal point, right? Right? That's what, so like if you have, right, we see this with 1/3, right? Where if we get 1 divided by 3, we have a bunch of series of 3s. But 2 divided by 3, we get a bunch of repeating 6s. But over here, we're getting 6, 6, 6, 6, 6, and a 5. You'll get some weird inconsistencies there with floating points on that like very last digit, which when you're doing scientific calculations, you're probably going to cut off anyway due to what's called significant figures, right, sig figs, which if you aren't into chemistry or biology, there's a certain level of precision that we ask for, but it's typically not this amount of precision, so you'll just simply say, hey, we just only need this number of digits, right? And you toss out the rest, or you round up from here. Now, the reason we've got this weird 5, to overly simplify, remember a computer does everything in zeros and ones. It does everything in what's called binary, which we'll learn later in the semester. And this conversion from base 10, decimal, to binary, base 2, and then back, leads to some inconsistencies, right? That's all that's going on there. That's why you, but as you can see, for the most part, it's perfectly fine, right? Now, for the most, probably the, let's go ahead and, I always forget what happens here, honest, right? If I do something like 5.0, divide 2.0, right? I'm trying to do integer division with two floats. It's kind of weird, and I'm never going to try to trick you with this one. It's just, I do it because I'm thinking about it in the moment, right? 5.0 divided by 2.0, right? 5 divided by 2 normally should get me 2.5, right? So what it's doing over here is that it's throwing away the decimal point and then converting it into a decimal point number, because we're working with floats. It's a weird one. Don't do this. This is weird, right? So anyway, more importantly is understanding what's going to happen like this. If I add 1 plus 0.5, will that work, right? I'm adding an integer and a floating point number. And the answer is, of course that should work, because that's math. What it does, whenever you do something like this, where you have an integer and a floating point number, it's just going to take the integer and convert it to a floating point number. Make sense? Right? So it's going to take that 1, turn it into 1.0. Everybody following? Python will almost always do what's called the least surprising thing, right? What should this happen? Should this crash, or should it convert into an integer into a floating point number so it can add them? It will convert them. Least surprising thing, right? Now, so you can add, so it doesn't matter. 5 times 1.2, it will work, it will convert it, that's perfectly fine, right? It's going to work exactly like you'd expect, right? Okay, so now what do we need to do? Well, let's see. Let's go ahead and talk about our other data types before we talk about our next operation, shall we? So our other data type that you'll primarily be using, it's one you've seen before, right? So we've covered integer, we've covered the floating point number, which is also called double. And if you're from a previous programming language, like you've learned Java or C or something else, what Java calls a float is a double in other programming languages. Double? You ask, for the people who haven't programmed before. Why is it called a double? It stands for double precision floating point. It's a certain standard for programming languages about how to encode a binary number into a floating point number into a binary representation. So, strings. These are the data types over here where we've got hey, we've got some text like hello, right? We typically, this was the stuff you were working with for Lab 1. Strings are noted by being in quotation marks, and they can be either single quotes or double quotes. Python doesn't care. You just whatever you open a string with, right? If I want it to be hello, I can't do this, right? It still thinks it's an open string, right? I opened with a single quote, I'd used a double quote, but in order to close it, I need to use a single quote, right? So this will give some weird error. Unterminated string literal, right? Literal being a literal term as opposed to a variable. Literal is is the term for something that is not a variable. We'll talk about variables in just a second. But just like, and this is kind of the weird thing, I think, but it's not too weird. You can do some operations with text. What do I mean? Hello plus world. Now, like I said, this is going to do the least surprising thing, okay? It's going to glue them together, right? This is what we call string concatenation, which is just the big fancy term for it, for gluing these two strings together into one big string, right? Hello, and then we had space world, right? We had an empty space here. If I didn't have that space, right, I would get hello, and then plus sign, and then world, and it doesn't matter if I have space between the pluses and the operands, right? That's the formal name for the things we're adding. It doesn't matter if there's a space between there or not, but visually it looks better, right? And without that space, as you can see, we get hello world, right? All one word. Right? Plus is that is the least surprising thing, right? And you can do this with multiple addition operations. Hello world plus, comma, how are you, right? You're right, you can just keep adding stuff. But what about subtraction? Does that make sense? Right? World minus whoa. Not really, no. Doesn't make sense. So Python's like, I have no idea what subtracting strings would be. Similarly for multiplying strings together, like this, right? If we tried to multiply things or divide these strings, we're just going to get errors because that does not make sense, right? Am I lost anybody at all, right? Adding strings together makes sense, but doing any other operation is kind of crazy, right? Okay, so there is one kind of other operation we can do with strings, which is kind of unique to Python. And again, I feel like this one makes sense especially once we see it, which is I'll do ha, or actually I'll do ba. Let's go with ba, and do plus na times 5. Okay? We already know that plus is an operation, is going to work. And if we do this, we get banana, right? A banana with too many nanas, right? Okay? Multiplication on a string, let's just do it with an A times 4, replicates it, right? We call this operation replication, right? So a string times a number will give us that string repeated that many number of times. It's niche. We don't need this operation in any programming language because we can do it with other tools, but it's useful. It's very useful, right? Right? And it's worth noting that, notice that it was not banana, it's not bana. It's not this repeated 5 times. It's ba, na, right? It did the multiplication before the addition. PEMDAS, right? The parentheses, exponentiation, multiplication, division, subtraction, addition. That rule still applies here, right? The multiplication will happen before. Yes? Yep, you either put it together, or if you always want to do, if you want something to occur a specific way, give me 1 second. If you want something to occur a specific way, always use parentheses. Give me 1 second. So here, sorry, parent, I learned how to type, I swear, right? Ba and na, we add them together, and then we do the multiplication operation, right? So you can put the phrase together first and then multiply. Does that answer your question? Yeah. Okay. Yep. And just also, using parentheses in general is a good habit if you aren't sure the way something is going to work and you want it to go a certain way. Just you throw it in parentheses. It will make it unambiguous, right? We've seen you've probably seen on Facebook or TikTok or whatever social media platform you prefer, you've probably seen plenty of order of operations stuff that relies off the ambiguity of phrases like this, right? And these are actually deliberately ambiguous, as opposed to this being a distribution operation versus a multiplication operation, right? Is this a division or a fraction? There are certain subtleties there that actually kind of make that are built into the way we do math which is the reason mathematicians use parentheses for this kind of stuff. Okay. All right. So later on, now there is one more data type, but we're going to figure it out later on, and it has only two values. But not sure. Let me turn off caps lock. True and false, which are Boolean data types, and we'll use this for logical operations later on. Okay? Much later. We're talking week 5, week 6 is when we start using this kind of stuff. So in the immediate term, what have we learned? You've got 3 data types that we care about: integers, floating point numbers, which are exactly the kind of things we remember. We've got strings, and again, to answer a question for those of you from another programming language, there is no difference between a character and a string in Python. There are just strings, right? So there are no characters. That's kind of unnecessary for this language. We've also learned that, PEMDAS will still apply, right? 4 plus, let's go ahead and do like 3 minus 4 times, 3 times 2, right? This operation over here will take place first, which will give us 6. Then it will become 3 minus 4, which becomes -1 plus 6, so it will give us 5, right? So again, the math here is, when I test you on stuff like this, I'm not really going to be testing you on this kind of operation. What kind of thing am I going to be testing you on? I'm going to be testing at you on, one of the questions on the exam always looks like this. Always looks like this, and you're not allowed to use a calculator. So, and it's not a trick question. It's actually fairly straightforward. It's an integer divided by integer using that double divide sign, right? What does that double divide sign mean? It means we throw away anything that's after the decimal point. Now we have a small number, we have a big number divided by a utterly massive number. This is going to be a value that's less, if we do this like on hand, by hand on paper, this is going to be 0 point something, 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 whatever. I don't even know. I don't care, to be honest. But what do we do with this? We throw away the decimal point and everything after it. Thus, the answer is?
0.
Yep. It's just a big fat 0. Integer arithmetic, it's worthwhile to know this. Okay? It's also worthwhile to know that that if I do something like this, 1, 2, 3, 4 divided by 10, this is a nifty trick that will come up later in the class, that if I do something like this, this stops being less about math and more about manipulating numbers. 1,234 divide 10. Dividing by 10 in this case, and just simply keeping it as an integer, is effectively saying, toss away that last digit, I don't need it anymore. Right? Less about doing math and more about doing a manipulation, right? It's less about getting the answer and what we're doing to the number. Okay, so with that in mind, let's talk about the rest of PEMDAS, right? We saw parentheses already, but then there was that other word in there, exponentiation, right? Doing 2 squared or 10 squared, right? 10 squared is 100, right? So how would I do 10 squared? Now, typically, when you do 10 squared on a computer, you write it like this. This is the first time I'm going to throw you, this should hopefully be the first curveball of the lecture, right? Typically, when you do exponentiation in like on a computer or on, like it will do this, but 10 squared is not 8. The hell's going on there? This is a quirk of being a programming language. These operations, and they are operations, these symbols have very specific operations in math. They're specifically what we call binary operations, or bitwise operations rather, because they work on binary numbers. This is what we call an exclusive OR, this is the OR, this is the AND. This is me also saying don't worry about this, don't bother taking it down with the notes. Just know that this does not do what you think it does in Python, right? And if you get it wrong on an exam, this is a point off at most, right? Because it's one of those things that you can immediately identify and go, oh yeah. So how do you do exponentiation? It's actually an operation that does make a lot of sense once you think about it. 10 squared is written as times times, right? You can do exponentiation by doing 2 multiplication operations. That kind of makes sense, right? Because exponentiation is basically supermultiplication, right? It's a really powerful form of making numbers big. So that's the first curveball. Now, there is one other symbol in our toolbox, because it really is a tool. We typically don't get into this kind of stuff in mathematics until you're working on really funky mathematics and like modern algebra and stuff like that. But that shouldn't deter you, because you've been doing this mathematics anytime you've done operations on like trying to figure out how a clock works. And this is called modular arithmetic. Okay? So this is, and mathematically, this is all about doing math in a confined space where the numbers wrap around. But that's a bunch of math here you don't need to know, right? This is all about kind of what effectively things do. So let's take a look at what this is. So this is another division operation. So let's look at 10. 10 divided by 3, right? If we do 10 divided by 3, that gives us 3 1/3 left over, right? If I do integer division, that gives me 3. Okay, right? Why? Because we just simply do 10 divided by 3, and then we throw everything away after that bit over, after this part. But our last operation, which we'll call mod, uses the percentage sign. That's what we do. We say this one is mod, okay? Or not, 10 mod 3 gives us 1. Now this one's actually not that scary. Mod gives us the remainder. So 10 divided by 3 gives us, right? I told you we're going back to 4th grade mathematics here. This is the quotient, and this is the remainder, right? It's pretty useful to be able to get the remainder if you can get the quotient, right? Everybody kind of remember that from 4th grade, the remainder, right? So if I do 16 mod 7, it's asking what is the remainder of 16 divided by 7, right? And that's 2, because 14 is the closest multiple, and so 16 minus 14 gives us 2, right? Right? 16 divided by 7, the way you would do it in 4th grade, before you learned about floating point numbers, before you did the decimal place, was you would write 2 remainder 2. Okay. 2 remainder 2. Okay. Likewise, another possible question on the exam is something that looks like this. And I'm just hitting the keyboard at random here. Mod 10, which asks, what is the remainder of this massive thing divided by 10? And the answer is obviously you don't have to do all the math to get the answer. Otherwise I wouldn't be asking it, right? Well, let's go ahead and ask a simpler question first, right? 34 mod 10, right? That would be 3, if we did 34 divided by 10, that would give us 3 remainder 4, right? There's 3 10s, and what's left over? A 4, right? Similarly, 124 mod 10. There's 12 10s, so the quotient is 12 mod, and the remainder is 4, right? So that's what's left over in the ones place, and we can't divide what's in the ones place. Similarly, 1777 mod 10, right? There's 177 as our quotient and 7 as a remainder. Modding by 10, right? When you divide by 10, the remainder is always what's in the ones place. Hence, if I do some giant number like this, mod 10, The answer is always what's in the ones place. So you can think of mod 10 as a way to get what's in the ones place. This is probably our most useful, this is one of the two main operations you're going to use for modular, which is to get what's in the ones place. Another thing we use it for is to mod by 2. 5 mod 2 gives us 1. 6 mod 2 gives us 0. 7 mod 2 gives us 1. 8 mod 2 gives us 0. Modding by 2 allows us to tell whether a number is even or odd. Make sense? So this is also what we do with a clock, right? If it is 8 o'clock and you want to know what time it will be 7 hours from now, 8 plus 7, and I'm going to put that in parentheses. If I want to know what time it will be 7 hours from now, if it's currently 8 o'clock, 7 hours from now, it'd be 3. Right? Why mod 12? Because a clock has 12 hours. This is what I mean when I say it's math that you've been doing your entire life when you've been using a clock. Right? Make sense? Now, why in the world did I have to put this in parentheses? Because, again, PEMDAS. Please excuse my dear Aunt Sally. In order to figure out what the remainder is, you have to do division. So modular arithmetic is a division operation. So it occurs before addition, right? So if I do this stuff without the parentheses, I'm going to get a wildly different answer. I will get 15, which is 8 plus 7 mod 12. Well, 7 divided by 12 gives me a remainder of 7, right? Can't divide. This is another common kind of trick. Any number that is smaller than its divisor will, just give us our full remainder. 7 mod 12 gives us 7. So 8 plus 7 is 15. So I figured today I'd spice things up today with a bit of a game. And apologies if you're watching this later because I do got to use the document camera to do this. Might as well drive the lesson home today. We are going to be playing a game called Chocolate Chili Roulette. This will involve a volunteer. There's no extra credit for doing this. And also, keep in mind that I won't be challenging you to a game unless, at least for the first one, I know that I can win. Okay? So over here, I have a grand total of 21 M&Ms. And I also bought some jalapeno peppers. Not particularly hot, I think, but just keep in mind they are jalapenos, and if you're particularly sensitive to them, that it exists. Okay, so we'll keep it to the side. Right, jalapeno there. Now, this is a variation of what we call the subtraction. The object of the game is as follows. Don't be the one to take the last piece. The last piece being, of course, our piece of pepper. Okay? So we have 21 pieces of chocolate, 1 piece of pepper. Right? So, you don't want to be the one to take the last piece. Now, your move is that you can take 1, 2, or 3 pieces. Make sense? Obviously, you want to take the chocolate first before you take the pepper. So the person who takes the pepper loses. Make sense? All right. Now, for this first round, I will go first, but any subsequent game, I'll be going second. Okay? So I will take our first volunteer. Now, please keep in mind, right, this is chocolate and peppers. If you're, if you have food allergies, just keep in mind, I don't want to have to pause this lecture to go and call 911, right? So just regular old M&M. So any volunteers for this game? Yes, you. Yeah, just come on down. Okay, now remember, your move is that you can take 1, 2, or 3 pieces. By the way, your name?
Jabbar.
Jabbar, nice to meet you. Everybody, give a hand. All right. So I will go ahead. There are 21 pieces here. I will go ahead and take one piece of chocolate. You'll take two. I'll take 2 pieces of chocolate. Take 1. Take 1. I'll take 3. Thank you for being a good sport. I'll take 3, and that's yours. Now, don't worry. I plan on fully being punished today by eating one of those. And you are more than welcome to take some extra if you need to wash out the taste. Okay? Everybody, hand. Now, I will go second. If you figured out the trick already, please feel free to punish me by giving me a pepper, but I will go second. Now, full disclosure, you were completely screwed the moment you came up, right? It's not so much rigged, but this is what we call a NIM game. It is a completely balanced game, and so long as I am going first and there's a certain number of starting pieces, I can't lose. And if I know the strategy. We'll be learning the actual game this is based off of, called NIM. This game is sometimes called NIM, even though it's not, later in the semester. But the subtraction game is very useful for teaching modular arithmetic. So, I will go ahead and pour out another 20. Let's see, 20. I did 21 last time, so why not make it interesting and do 22? So, 1, 20. 22. Yes. That is 22 over here. And, right. Anyone else want to come down here and go first? Yes, please come on down. All right. And your name?
Kevin.
Kevin. Everybody give Kevin a hand. No. You get to you get to go first. Choose as many as you want, 1, 2, or 3. Okay, you chose 3. I will choose, let's see. I will choose 3. Gonna get really fat today.
Choose 2.
See? I'll choose 2.
Choose 1.
No. No, that's okay. Feel free. Do you need some water?
No, I have water.
Okay. Everybody give Kevin a hand. All right. Now, I fully expect to be eating this one. The game will continue until I lose. Now, that being said, let's go over the strategy now. Let's go over the strategy now. Now, this is a lecture on math, so we will go ahead and go over the math. All right? Whiteboard. Okay. All right. So because we're going to be doing this in terms of math, I'll be annoying, and we're going to define 2 variables here. We are going to define n. Let's go ahead and use something a bit thicker. Okay? N is the total number of pieces. We can either do the math as being the total number of pieces of chocolate or the total number of pieces overall. If we're defining it in terms of the overall number of pieces of chocolate, then we want to be the one who takes the last piece of chocolate, right? So I'm going to do it this way first because the math is easier, okay? I want to be the one who takes all the chocolate, okay? So N is the number of pieces of chocolate. K is the maximum number of pieces I can choose, right? Here, you could choose 1, 2, or 3, right? So the math works as follows. On your turn, you want to choose pieces such that what remains is N mod K equals 0. In other words, and since we're playing with 3, let's go ahead and just replace our math. N mod 4 equals 0. If you've played Mario Party, by the way, this is a game in a few Mario Party games, although with multiple people. So in other words, what I was doing, I was always choosing pieces such that, and you notice I even had them grouped out in groups of 4. I would always choose the number of chocolates such that I'd be completing the set of 4 chocolates, right? So on my opponent's turn, they were left with 4 chocolates, and they could never take all 4 of that group, right? I'd complete whatever they were taking, so on the last one, they would have to eat that pepper. So N mod 4 is equal to 0. This game is sometimes played with just, like paper clips or something. And obviously, you don't eat the paper clips. That'd be a bad idea. But in that case, right, you don't want to choose the last piece, right? In which case, the math is N mod 4. And this is including, if it was the pepper, if you were including the pepper in the math, it's N mod 4. The remainder after we divide by 4 is equal to 1. But this is the math you want to use here, right? N mod 4, the number of pieces of chocolate. So with that in mind, let's go ahead and that is 1 piece of pepper, even though that's broken into 2 pieces, so we'll count just in case. That way, I'm not up into any tricks. This is 1 piece of pepper. So as you can see, if I can do that math and I go first, I'm in a winning position. So hence, but the minute one of you slips up, I can get that advantageous situation and then force you to eat the pepper. Okay. So let's see how many we've got here. 4, 8, 12, 16. So we have got a grand total of 19. That seems good. 19. So we've got, what is that? I said it was 19. Let's go ahead and count it out. 5 again. 5, 5, 5. So we've got 19 pieces of chocolate, 1 piece of pepper. Okay. Let's see. I want to make sure you can still win if you're going first, because I think all I have to do is just, yep. Okay. So who wants to go? Yep. Just double check the math again. I don't want to be accused of being unfair. Yeah, okay, that's 19 there, right? Double check yourself.
It's
19. Okay. So, yep. And how many did you take? 2. Took 19.
The projector's on.
Oh, the projector's off, right. Took 19. So there was 19. Yep. That's okay. Now you're go ahead. Now everybody give him a hand. Now the mistake was the first move. You didn't knock it down to a multiple 4. So anyone want? All right, who wants to go next? Right, let's pour out some pieces because I'm starting to get way too much chocolate into me. All right, 4. Let's go ahead and make sure we've got. Okay, so 4, 8, 12. Let's go ahead and let's go ahead and keep this a bit shorter because I'm starting to get way too much chocolate. We've got 14 pieces of chocolate, 15 pieces total. 14 pieces of chocolate. Who wants to go? All right. All right, and your name?
Zainab.
Sorry?
Zainab.
Sena?
Zainab.
Zena?
Z-E-Y-N-A-B.
Zimba?
Zainab.
Zinab. There we go. Okay, sorry. I believe it or not, I am hard of hearing. So, okay, Zinab. Everybody give Zinab a hand. All right. All right. Go ahead. You get to go first. Count carefully. What does that leave you with? Okay.
And I have 3.
You have 3. Go ahead. All right. That was 4, but whatever. At this point, I need to make sure I don't have any chocolate. All right. Everyone gives Zinab a hand. Again, all right, one more time. The key here is to reduce the number that we start with to what? To multiple 4. If you can choose 3, right? So let's go ahead and do this. 1, 2. 14 again. Next person. Do you want to go or? Okay. We have 14 pieces of chocolate, and you can choose 3. So you can choose up to 3.
Okay, so just pick one.
Mm-hmm. Oh, there we go. Let's see. There's an extra one there, I think. That was.
I took 3.
Mm-hmm. I think we all miscounted because there was an extra one there. And I don't want to have. See? Much harder than the one I had yesterday. All right. All right. Now, just in case, now for those of you who didn't get the chance to play, you'll get the chance to play on your exam. The question will be, given this many pieces, and you can take 4, and you can take this, and you can take this many, how many, and you get to go first, how many should you take? Don't worry. Whew, that was hot. Like a lot harder than the one yesterday. Whew. All right. Let's switch back to this. Another reason I brought this. All right. So, 2 more things to talk about today. Hopefully that was a bit of a fun diversion for everybody. 256. Ow. All right. So, let's go ahead and talk about variables. Variables are basically our boxes, as I like to call them. Right? So we are used to variables like something called x is equal to 5, and we can go back and get the value and retrieve the value 5. Right? Let's go ahead and start by putting this into a window, a full programming window over here. Right? X is equal to 5. Print the value x. And what the equal sign does is that this is probably the the trickiest conceptual thing to do here, okay? Conceptually, this is probably the trickiest thing, which is that this, we read it as equals, but it is the assignment operator. In terms of order of operations, this is just like another operation, just like plus, just like minus, I know that's weird to think about, but it's an assignment operation. It takes the thing on the right and puts it on the left. And in terms of order of operation, it goes dead last all the time, no matter what. Right? Makes sense, because you got to evaluate what's on the right in order to store what's on the left. It takes an expression on the right, so it can be as complicated as we need it to be, 5 times 2 to the 18th power, right? As complicated as it needs to be, and takes that result and stores it on the left. Now, why do we use the equal sign, even though I'm saying this is not checking if 2 things are equal or setting 2 things equal, and it's just an assignment operation? We used to use a few different terms for it, like a better representation of it, and typically what we show on paper is this symbol, right? Pointing this way, right? And let's just simplify this for a second. But that can easily be misread as x is not x gets the value of 5, but x is less than -5, which is less than useful. And this just becomes absurd and annoying to type, right? Other programming languages, I believe like Pascal, they used this operation, which we lovingly call the walrus operation, because it looks, if you flip it on its side, it looks like the eyes of a walrus with his little tusks, right? And this is what's used in some, Google's Go actually uses this as an operation. It's pretty nifty. But eventually that just got simplified to X, because it means similar things, but it's the assignment operator. And what's important is to know is that you can pretty much make these variables as big as we need it to. Like, I can do something like this. Num students is equal to, I think, 158, right? I can make these variables as big as I need to, like in terms of the size of the name. We aren't constrained like mathematicians who are working on paper to basically say, oh, this value is X, Y, right? Make sense? So num students is equal to 158, right? But I'm going to go back to our abstract math for a second, because I've been emphasizing this is the assignment operator, okay? what does this mean? Okay. X is equal to 5. Y is equal to X. Okay? Print out X and Y. X comma Y prints out those two results. Oops. Okay? And you get 5 and 5. Unsurprising, right? 5. Right, what goes on? We take 5, we put it into X. When we say Y is equal to X, what we're doing is we're asking ourselves, let's look inside of X. What's inside X? 5. Stored inside Y. Right? And so we print out and we get 2 5s. This is probably, and this next part is the part that is, it makes sense as long as I've said the previous sentences, okay? Y is equal to, Y is equal to X, sorry, Y is equal to 6, right? So obviously Y's value is going to be 6. What is X's value going to be? It's going to be 5, because we are not creating a hard binding between Y and X here. We aren't saying X and Y are the same variable, right? We are saying, let's take what's in X stored inside Y. So if I do something weird like this, which you can do, by the way, Y is equal to Y plus 10. This doesn't make sense in normal kind of math, but we'll do something like this all the time. Okay? How does this work? You take what's on the right, Y is 5, add 10 to it, store the result in a variable. That variable just happens to be Y, which is, so we store 15 in there. X's value does not change. And that might bug you, but the reason is, do you really, when you've got 20 variables, and some of them are set in relation to each other, or initialized in relation to each other, do you really want to be the one who has to keep track of all that? You do not. You do not want to have to keep track of like those interchanges. That's why we do it like this. Now, that game took a bit longer than I wanted it to, but variables, again, they operate just like your algebraic variables otherwise. So for our final bit of, yes?
So when you set a variable, the last value you set is the one that is going to, like if I say Y is equal to 5,
Uh-huh.
I say Y is equal to 10.
Yep, it's the most recent update, right? So this just simply, it's variables are boxes that can hold one thing. And we stored 5 in there, then we stored 15, then we stored the value happy in there, right? So it's just going to update in order. Let's go ahead and open up the textbook for a second, because this is a really awesome tool, the textbook, to answer your question, right? Or to help answer your question on your own. Well, you know that heat is finally starting to die down. This was a good choice for the jalapeno. So let's go ahead and go. No, I don't want it to be. Okay. We are going to go to Runestone Academy. I'm going to log in, and you should too, because we're going to do a short exercise as well. Very short. Okay? And I'm going to go to our textbook. Now, over here on the top of the page, if I zoom out a bit, right, if you're zoomed in like this, you'll get a hamburger menu, which just simply can send us to everything. But you want that pen, or you want to get to some code block, right? And over here, let's go ahead and put this in to X. So I'm going to do what I had over here. Okay. Pain. X is equal to 5. I know it's going to be hard to see for a second. X is equal to 5. Y is equal to X. Y is equal to 6. Right over here? This button over here, this pen. Okay. Or you can use literally any text box inside any code block in here. But what I'm going to show you is one of the functions, one of the buttons over here. And then Y is equal to happy. You don't need to follow along with this because what's more important is not saving and running it, because it's not going to do anything because I didn't tell it to do anything other than store variables, so it's not going to report back to us. Hitting this button called Show in Code Lens. And this opens this up down here. And this is fantastic over here. And I've zoomed in a bit. It's annoying. Okay. And it says visualize with Python Tutor. We can go there. So what we see here is a little bit of a thing that runs through your code one line at a time. It's brilliant, in my opinion. So here we've got x is equal to 5. We press the next button and it runs through that and it gives x and says x5. Y is equal to x. Sets up the variable. Y is 5. Y is equal to 6. Sets it to 6. Y is equal to happy. Y is happy. Right? So this tool, Showing Code Lens, this button right over here, is excellent for kind of breaking down and seeing how the code works. This is especially good for loops. Now, not completely done yet. We do have 15 more minutes, and I plan on using them. So, now that you're here, please, yes? Sorry? Runestone.academy. Okay, and if you haven't signed up for it yet or something, you can just follow along with this last bit later. Okay? This is extremely simple because, again, we only have 15 minutes left, but this is a very simple project. And so, preview of what we're going to do in week 3 for module 3. Driving the turtle, right? Printing out stuff, not very interesting, right? Not the most interesting thing in the world. So what we're going to do is we are going to go to project 2 called Driving the Turtle. Otherwise, if you want to get there, you can click on modules. You're going to go to Canvas, click on modules, scroll down to module 2 overview. Scroll down over here to this link over here and click on it. And it'll bring you to the same place. I think. Come on. Yeah, it will. Fall 2025 Rosen. I don't know why it's not. There it is. Okay. And it'll bring us to this program. A very simple program, although it looks very complex at the moment. Okay? Now, this is called the turtle module. It is graphics. It's some basic graphics. It is a mode of programming that was designed for the Logos language in, I think, the 1960s or so, but it's been implemented in a bunch of other languages because it's a very nice paradigm for doing graphics and learning how to code. And it works like this. I'll just go ahead and hit save and run. We've got a green arrow over here, and if you could see it, we basically run it, and you've got basically this thing that moves. What is this thing, that little arrow over here, let me zoom in again, is our turtle. Now the way you visualize this is that we are looking at a bird's eye view from down over here on a giant sheet of paper. Okay? A giant sheet of paper. This arrow is our turtle. Okay? And let's just go ahead and comment out this code for a bit. Comment. Okay? Save and run. And what he is that he's just a little turtle with a pen attached to his tail. And as he moves, he drags the pen or the paintbrush across this giant piece of paper and draws for us. And we give him very simple commands. We tell him to, basically his commands are, we can tell him to move forward, right? So over here, let's look at this first 4 lines of code. So first off, we have our first 2 magic lines. I try to use as little magic as possible. Things that I say, just do it, I can't explain it, right? Right now, we're not at the point where we can explain this yet. So this is just magic over here. Import turtle, and then we create a variable called myTurtle is equal to turtle.turtle. That's weird, right? Turtle dot, then uppercase turtle. But as it says, it creates a turtle. But from then on, we've got a variable. Now, this variable is a turtle. It's another data type. But there's basically an infinite number of data types than the ones I went over today in class. But those are the ones I went in class today are the 3 you really need to know. Turtle is a more complex type called an object, and which basically can do a lot of things. But Like one of the things he can do is he can change his color to green. That's what this first command does. MyTurtle.color is green. Sets the color. And then we can tell him to move with very simple directions. Forward, 50. That moves him forward 50 pixels. If I change that to 150, he moves forward a lot more. 3 times as much, in fact. Now, there's this interesting thing over here we can do. MyTurtle.up and MyTurtle.forward another 50. And if we run that, notice that he didn't draw anything over here. Up and down doesn't move him up and down, because again, we're telling his commands to move our forward and backwards. Up and down tell him to lift his tail up and put his tail down. In other words, is he going to draw or not, right? So he moved forward 150, then we told him up, and then we told him to move another 50 forward, okay? Now, to get him to do anything, to go other places, we can tell him to go to turn. Right dot 90. And now look, our turtle is facing that way. Let's go ahead and move him forward only 100 so he's not off on the side. Right? Right? We told him to move forward, then we told him to lift his tail up, then we told him to move forward again, so we didn't draw a bit, and now we told him to turn right 90. 90 what? 90 degrees, right? Least surprising thing. If you tell him to turn right, he's going to go right 90 degrees. If I told him to go left, he'd go left 90 degrees. Very kind of basic kind of things over here. MyTurtle, that down. Tells him to put his tail down, so we'll draw again. And then MyTurtle, that backwards 100. And then he moves backwards. I don't know if turtles are really good at moving that quickly backwards, but apparently this one is. So this is really it. We can, and we're going to find out that we can do a lot with just a little bit in this. We can draw some very cool, shapes with this and very cool patterns with this. But for right now, your goal is to take the second text box and just play around with it, moving it up, down. Feel free to copy the code and modify it over here, right? Does it take different colors other than green? Of course it does, right? It takes red just fine, right? Can I change the color in between? Of course you can. Can I do one thing or another? Yeah, there's a lot of things you can do with turtles. Play around with it for a bit. But this is a very straightforward kind of thing. Now, I personally find, this is just my suggestion, I personally find that typing MyTurtle_turtle is a bit of a pain in the butt. So, and it's very impersonal. I always like to give my turtle the variable name, Bob, because it's 3 letters, 1 syllable, and very easy to type, right? And so I can tell him Bob.forward 100. There is one last command I'll give you, because I did mention that what was the minimum math you really needed to know? Cartesian planes, or as I called it, a Euclidean plane. Math Bob.goto -100 and 50. That's right, this piece of paper is just a giant XY plane. That's all it is. So you can tell them to go to a specific point on this plane, right? Now, of course, on an exam, I'm not going to tell you to do anything that's going to require a protractor, but like you can use this as a tool to play around with, right? So go ahead, try playing around with this, moving it forward and backwards, okay? Because we've got a few more minutes. Just take a few minutes to kind of play around with this. And then that's it. Yeah. So, did you create an account for this yet or no? Oh, total 25,000. It should be. That's wrong. There's space. Oh. I know. It's sometimes really hard to see. No worries. The only reason I need to look for that is I've made that mistake too many times.
Yeah, I was the issue.
There you go. Yes.
I have a question. So is my version not updated for it to run?
Put it down over here. No, it's just you haven't given it any. You haven't taken. So first off, let's go ahead and you want to do that. Let's go over here. Okay. To the text, and then you want to do it in here, so you'll get credit for it. Let's go ahead and run this. And then what it is that you created the turtle, but you didn't tell it to do anything yet, so that's why it wasn't moving. All right. When you are done, feel free to leave. If you're having issues, please come up and let me know. Feel free to come down and take as many M&Ms as you want, by the way. You know, that's a bit too many for me to eat. Yep, I'm just going to pour some right over here so that students can. Usually get some. So. Yep, you go to the aisle, you get something over here. Well, let me stop recording.